Hello guys and welcome. On today's video, I'd like us to discuss a technique that we use to solve a system of linear equation called Cramer's rule. Okay, so let's suppose we have two equations, a1x plus b1y is equal to c1, and you have a2x plus b2y is equal to c2, where a2, a1, b1, b2, c1, c2 are constants. Okay, so we want to solve for x and y simultaneously. So the first thing that we want to do is to eliminate y and find x. Okay, so if we are to eliminate y, we can multiply. Let's call this one equation 1 and this one equation 2. Okay, so we can multiply equation 1 by b2 and multiply equation 2 by b1. Okay, so once we do that, we're gonna get we multiply equation 1 by b2, so it's gonna be a1 b2x plus b1 b2y is equal to c1 b2. Okay, then this one we multiply it by b1, so we're gonna have a2 b1x plus b2 b1y equals c2 c1. Okay, then we subtract those equations. Okay, so we can say equation 1 minus equation 2. So once we do that, y is gonna go away there. Okay, so we're gonna end up with a1 b2 minus a2 b1 all multiplied by x equals c1 b2 minus c2 c1, just like that. Okay, so now we are solving for x. We're going to divide both sides by this. Okay, so we're gonna end up getting x equals c1 b2 minus c2 c1 all over a1 b2 minus a2 b1, just like that. Okay, so if we try to remember how we find out the determinant of a 2 by 2 matrix, we see that we can rearrange this in a form of a determinant. Okay, so we can say, okay, here we can have c1. Since it is multiplied with b2, we know that b2 has to be somewhere there. Okay, then from this side we can have c2 here. Okay, it was supposed to be b1, not c1. Then I can also go fix there, and also this one. Sorry about that. So that is b1, not c1. Okay, yeah, then we can also write b1 here like that in a form of a determinant, then divided by, we do the same with the equation in the denominator. We say it's a1, so it must be multiplied with b2, then a2 b1, just like that. So if you take notice of something, is that here at the numerator we have the coefficients of y and the constants. Okay, we excluded the coefficients of x. So that is basically what happens when you're doing Cramer's rule. You exclude the coefficients of x in order for you to find the value of x there. Okay, so this basically, now we can say it is dx, the determinant of x divided by d. So the determinant, it is found directly from taking the coefficients of x and y, just like that. Okay, so we see it's a1 a2 b1 b2, so that is x. So similarly we can do the same for y. Okay, so now what you are going to do is that you are going to say equation 2 minus equation 1. So at the end of the day, we're gonna end up having y being equal to, you can go and try that yourself and see if ever that is the case. Okay, so it's going to be a1 a2 then c1 c2 divided by a1 a2 b1 b2, just like that. Okay, so that will just basically be dy, where dy is the determinant of y divided by d. D is the determinant of the whole system of equation. So now we can try an example and see if ever these two equations that we get for x and y are going to give us the correct answers. So the first thing that we have to put in mind, since we see that we are dividing by d, we know that d must not be equal to 0. Okay, yeah. Now let's look at an example. Let's suppose you are given something like 2 1 minus 2 4 as a matrix, then that being multiplied by xy, and it must be equal to 2 and 3, just like that. Okay, so from this we can make what you call system of linear equation. So if you multiply this by that, we're gonna have the first equation 2x plus y. It must be equal to this first element there, 2. So the second equation is basically minus 2x plus 4y equals 3, just like that. Okay, so the first thing that we want to find is the determinant. So the determinant d is going to be 2 by 4, that is 8, then plus 2 by 1, which is 2. So the determinant there is 10. Okay, so we know that x is given by dx over d, and y is given by dy over d, just like that. Okay, so we want to find dx and dy. Okay, so x is going to be, what is dx? We take the coefficients of y and this constant here, we exclude the coefficients of x. Okay, so that is going to be 2 3. According to that formula that we did, we start with 2 3, then it goes to 1 4, just like that. Then it's going to be divided by d, which d we already found to be 10. Okay, so if we simplify this, what is going to be the determinant there is 2 by 4, which is 8, minus 3 all over 10. So basically x is going to be 8 minus 3 is 5 over 10, then that is 1 over 2. So x is half. Okay, so for y, we're gonna say y is equal to, what is dy? We are going to exclude the coefficients of y, so it's 2 minus 2 minus 2, then 2 3, 2 3, just like that. Then that will be divided by d, where we know that d is 10. So basically y is equal to, what is this determinant? 2 by 3 is 6, 2 by 3 is 6, then plus 4 over 10. So y is equal to 1. 6 plus 4 is 10 over 10 is 1. Okay, so we see that we have our solution for x and y, where they are equal to half and 1, like that. Okay, so that is the solution. We can test that these values satisfy our equations. If we sub half there, we're gonna get what? 1, then plus 1, y is 1, so that is actually equal to 2, so it is true. Then if we sub half again there, we're gonna get minus 1, and if we sub 1 there, we're gonna get minus 1 plus 4, which is equal to 3. So that satisfies both our equation. So now let's look at when we have a 3 by 3. Okay, so looking at when we have a 3 by 3, how are we going to go about it? Let's suppose for a 3 by 3, we got 3 systems of equation. Okay, so I'm gonna start with the general way. So it's a1x plus b1y plus c1z, it must be equal to d1. Okay, then the next equation, we can say a2x plus b2y plus c2z must be equal to d2. Then the final equation, a3x plus b3y plus c3z must be equal to d3. Okay, so these are going to be the short notes that I'm going to make for you guys, so that you can understand what is actually going on. The first thing that we'll want is the determinant, where the determinant is actually represented by d. Okay, for the determinant, what we do is that we use coefficients. So what I mean by that, we use coefficients. It implies that D is going to be coefficients is a1, b1, c1, a2, just like that. Okay, so I'm gonna write them in a column: a1, a2, a3, then b1, b2, b3, b3, and c1, c2, c3, just like that. Okay, so the way that we are going to find this determinant is by cofactor. So we're going to say this first element a1, then we cancel first row and first column like that, then multiply it by the mean. How we are already familiar with finding the determinant of a 3 by 3. So that is the same case. Okay, so I'm not going to waste time doing that. So now let's further go on and find out how are we going to solve our system of equation. So in this case, x is still given by the determinant of x divided by the determinant, and y is given by dy divided by d, and z is given by dz divided by d, just like that. Okay, so now what we have to find is dx, dy, and dz. So for dx, what you have to keep in mind is that we exclude coefficients of x. So if I'm excluding coefficients of x for dx, then it should automatically make sense for you to say for dy, we are going to exclude coefficients of y. Then for dz, we are going to exclude what? For dz, we are going to exclude coefficients of z. Okay, so now let us compute the matrix for for dx, dy, and dz. Okay, and see how we go about them. So for dx, before I do that, let me just write a rule that I follow that helps me. So that rule says a or d first and c or d last. Okay, so using this, that is how I'm going to formulate the thing. Okay, so for dx, let me put a, b, c, and d, just like that. So a will represent all the coefficients of x, b coefficients of y, c coefficients of z, and d the constants, just like that. Okay, so for dx, we know that we exclude coefficients of x. That means we are fighting with a, so that we don't want a there. Okay, we don't want a there. So according to this rule, it tells us that a or d first. So since for dx we are fighting with a cannot be there at all, so it can't be first. The one that is going to be first is d. So d goes with the coefficients d1, d2, d3, just like that. And which one is going to be last? Already we have d, so here it's your d last. That means c is going to be the last. So c goes with c1, c2, c3. Then the one that is left off is b, b1, b2, b3. So that is how you find the determinant of dx. Then you compute it by cofactor, the way that you are used to doing the determinant. Okay, so dy, we are excluding b. Okay, so since we're excluding b, we're excluding coefficients of y, that is basically b, b1, b2, b3. We don't want that, so we're going to follow this again. It says a or d first, so that means a is the first. Okay, so a comes first on this method that I'm using. So a comes first. That means I'm gonna have a1 there, a1, a2, a3, just like that. Then it says c or d last, so the last one will be c, since y doesn't have any problem with c. So here you're gonna have c1, c2, and c3. So the only one that is remaining now is d1, d2, d3. I can't say the remaining is b because y is fighting with b. B are basically the coefficients of y, so those are to be excluded. Remember from that statement there. Okay, so for dz we're gonna do the same. So to find the dy, you have to expand this determinant by cofactor. I'm pretty sure everyone is familiar with that. If you forgot how to do that, just feel free to look onto other videos that I've uploaded. There's a previous video where I was explaining that. So for dz, we are going to exclude the coefficients of z. So that basically means that we are fighting with c now. Okay, so if we are fighting with c, the first rule say a or d first. That means a has to be the first one. So we have a1, a2, a3, just like that. And the last one is going to be what? C. It says c or d first, but we know for z we are fighting with c, so c can't be that all. Then the last one has to be d. Okay, so the last one is d1, d2, d3. Then the middle one is going to be b1, b2, b3, just like that. Okay, so yeah, that is how you are going to find the things. Then you, if we have dx, dy, dz, we can solve for x, y, z. Okay, just like that. So let's look at an example quickly. Yeah, here's the question. They give us 3 equations. Let's solve for x and y using Cramer's rule. So the first thing that I will do, I'll put a there, then put b, then put c, then d. Okay, just like that. Then on the side here, I'll write, let me just put it here, a or d first, then c or d last. Okay, so the first thing that we'll need to calculate is d, where d is the determinant, where we agreed that we're taking the coefficients alone. So that is going to be 3 minus 2, 3, then 1, 5, 2, then minus 1, 4, 1, just like that. Okay, so expanding that using cofactor, what am I going to get? I'm going to say, let me use the first row. So it's going to be 3 multiplied by 5 by 1, that is 5, then minus 8, then minus 1, so this one, then we cancel that, so we remain with minus 2 by 1, that is minus 2, then minus 12, just like that, then minus 1, and minus 1 by minus 4, minus 50, just like that. So if we simplify, here we're gonna get minus 3 by 3, that is minus 9. Then here we're gonna get minus 14 by that minus, we get plus 14. Okay, then here we're gonna get minus 19 by that, then it's plus 19, just like that. Okay, so this is going to be simplified to what? It's going to be simplified to, so this is going to be minus 4. Yeah, just like that. So the determinant is minus 4. Now we need to look for dx. So dx, we are going to exclude the coefficients of x. So excluding coefficients of x is basically we are fighting with a. So using this, a can be first. That means d must be first. So d, we see that is 0 minus 1, 1. Okay, so we have 0 minus 1, 1. Just like that. And which one is going to be the last is c. So c is minus 1, 4, 1. Okay, so minus 4, minus 1, minus 1, 4, minus 1, 4, 1, just like that. So in the middle row, we are going to have 1, 5, 2, just like that. So I can use this one to find the determinant. So it's going to be 0 by anything, still going to be 0. Then I go to the next one. Sorry about that. To the next one, I have minus 1 by minus 1, minus 4, then minus 1 by minus 2, minus 2, minus 5, just like that. So when I simplify that, this is minus 5 by that, it's gonna be 5, and this is minus 7, then it's plus 7. So that is going to be 12. Okay, then since I have dx, I can say therefore x is dx over d. I got it. So if x is dx over d, dx is 12 and d is minus 14. So we have 12 over minus 4, minus 4. So how many times that's 4 going there? 3 times. So minus 3. We get x as minus 3. So now we can find dy. So dy, we are fighting with the coefficients of y, which is b. Okay. So a is going to be first. So that means we are going to have 3 minus 2, 3. Then on the last one, we are going to have c. C is minus 1, 4, 1. And in the middle row, we're going to have d, 0, minus 1, 1, like that. So I can use this to find the determinant. We'll say 3 into minus 1 minus 4, then plus 0. So this 0 is going to annihilate everything. Then minus 1 into minus 2 plus 3, just like that. So this is going to be minus 5 by 3 is minus 15. Then this one is going to be 1 by minus 1, that is minus 1. So here we get minus 60. Minus 16. So dy is minus 16. That means y, since we know is dy over d, is going to be what? Minus 16 all over minus 16 all over d is minus 4. Minus 4, then that implies y is going to be 4. Okay, so now we can find dz. Quickly, let's find dz. Dz, we see that we are going to be fighting with c. We don't want that. Okay, so the first one is going to be, according to this, is going to be a. So it's 3 minus 2, 3. Then the last one is going to be, we are going to find with c, right? So c can be the last one. That means the last one must be d. So that is going to be 0, 0 minus 1, 1. Then the middle one is going to be b, which is 1, 5, 2. Just like that. Okay, so I can utilize this column to do the things. Okay, or the first row. So let me just use the first row. So it's gonna be 3 multiplied by 5 plus 2, then minus 1 multiplied by minus 2 plus 3, just like that. Then the last one is 0, so it's just gonna be 0. So this is going to be 7 by 3, which is going to be 21. Then this is going to be 1 by minus 1, which is going to be minus 1. So we get dz to be 20. So if dz is 20, then z is going to be dz over d, and we know dz is 20 and d is minus 4. So that is going to be equal to minus 5. Okay, so now we have found all the values of x, y, and z. So our solutions, x is minus 3, minus 3, and y is 4, then z is minus 5. Okay, so those are the solution to this system of equation. So this is how you apply Cramer's rule, guys. So if you didn't understand some of the concept that we were doing here, feel free to rewind and take things bit by bit slowly. It will make sense. So this I just created such that you guys can see which ones we're supposed to put there and which one we're not supposed to put there. Okay, so this thing is not there in the slides or in the textbook or anywhere. It is just some creative thinking that I came about. So yeah, thank you so much for watching, and don't forget to subscribe and share the video.